Peace be upon you. Welcome to the chemistry session. Separation technique is our lesson. The objective is explain one of the separation techniques used to separate liquid-liquid heterogeneous mixtures. It's known as decantation using a separatory funnel. Let's recall back. Matter are classified according to their constituents into pure substance and mixtures. Mixtures also classified into homogeneous and heterogeneous mixture depending on the number of phases. Heterogeneous mixture could be solid-solid, solid-liquid, and liquid-liquid. The separation techniques used to separate solid-solids are magnet picking and hand sorting, while for solid-liquid are decantation, filtration, and centrifugation. Help a friend. My friend mixes many liquids together as shown in the picture. Could you help him by proposing a method to separate each liquid alone? Yeah, think. Good. Use a syringe or a sucking straw. But don't forget, we couldn't use our mouth in the lab. So, let us think about a separation technique used in the laboratory to separate the different liquid layers. Open your booklet on worksheet 7, then read the name for our new separation technique. This is the header. Yes, it's decantation using a separatory funnel. Good. Let's read the introduction. Two or more immiscible liquids that can be homogeneous when mixed together form a heterogeneous mixture like water and oil. To separate the constituents of a given mixture, we refer to decantation using a separatory funnel. What is the state of the mixture that we'll use? Yes, it's two or more immiscible liquids. What is the nature of this mixture? Good, it's heterogeneous mixture. Give an example about a liquid-liquid heterogeneous mixture. Nice, it's water and oil. Teacher, could you explain what you mean by the word immiscible? I didn't understand it. Sure, sweetie. Okay, to understand miscible and immiscible liquids, we'll take an example. Prepare two mixtures. The first one is water and alcohol. The second one is water and oil. As you see, look at the first mixture. What is the difference between it and the other? Liquids here mixed, while in water and oil, liquids don't mix together. And in the first one, we'll see only one phase, then it's a homogeneous mixture. And in the second one, two phases are obtained, oil phase and water phase, then it's heterogeneous mixture. That's why we call the first mixture as miscible from the word mix, while the second one is immiscible. Now it's your turn to define miscible and immiscible liquids. Good. Miscible liquids are liquids that mix together to form a homogeneous mixture, while immiscible liquids are liquids that can mix together and form a heterogeneous mixture. But how could two immiscible liquids, oil and water, be separated? Let's watch the video.
Funnel. To do this experiment, we require a separating funnel, stand with a clamp, mixture of oil and water, filter funnel, and beakers. Take a filter funnel and place it on the mouth of the separating funnel, which is clamped to a stand. Pour the mixture of oil and water into the separating funnel through the filter funnel. Oil and water will appear as separate layers. Remove the filter funnel from the separating funnel and close the separating funnel using a lid. Take the separating funnel from the stand. Invert the funnel and shake it gently and slowly open the stopcock of the funnel to release the pressure inside the funnel. Place the separating funnel in the stand and allow the two liquids to separate completely. Oil forms the top layer and water forms the bottom layer. Take a beaker and place it below the separating funnel. Open the stopcock of the separating funnel and pour out the lower layer of water carefully onto the beaker. Close the stopcock as the oil reaches the stopcock. Take another beaker and place it below the separating funnel. Open the stopcock and now collect oil from the separating funnel. The immiscible liquids separate out in layers depending on their densities. The denser liquid will fall to the bottom, forming the lower layer, and the lighter liquid forms the top layer. Water is denser than oil.
Now, pause the video and try to label the picture that we have. Yes, oil, water, separatory funnel, Erlenmeyer, and a stand. Suggest a procedure to separate water and oil using separatory funnel, referring to the video. Don't forget. The first one is fill the separatory funnel with water and oil. The second step is wait 5 minutes till the water and oil are totally separated, as seen here in the figure. The third step is open the stopcock, allowing water to pass into an empty beaker placed under the separatory funnel. And the last step is close the stopcock when the water passes completely, leaving the oil behind in the separatory funnel as shown in the figure. Let's recall back the physical properties. Density, boiling point, size of particles. What do you mean by the density? Look at the picture. The water settled and the oil flowed because of the difference in densities, and water is denser than oil. Then it will sink. While boiling point, the mixture starts to boil at definite temperature known as boiling point. Size of particles, the small particle size will pass through the pores, leaving the larger behind on the sieve. What is the physical property that decantation using separatory funnel depends on? Whether it depends on density, boiling point, size of particles. Let's check. How many phases do you see? We have a water phase and oil phase. Then it depends on what is the physical property? Good, it's density, since two layers are observed. Fill in the following map. Hand sorting, magnetic picking, decantation, filtration, centrifugation, and decantation using separatory funnel. Now let us recall back the difference between miscible liquids and immiscible liquids. Miscible liquids, liquids which mix together, while immiscible don't mix together. Miscible liquids are homogeneous mixtures show one phase, while heterogeneous mixtures for immiscible liquids with two or more phases. Stop the video to evaluate yourself. Evaluation. What do we call the technique in the adjacent figure? Look at it. Yes, it's decantation using a separatory funnel. Name a glassware A. Look at a glassware A. This is glassware A. What do we call it? Nice. It's separatory funnel. For which kind of mixture is this technique used? Look at it. Yes, it's used for nice liquid-liquid heterogeneous mixture. Which is the answer? Liquid 1 or liquid 2? This is liquid 2 and this is liquid 1. Yes, which one is the answer? Liquid 2 is the answer since it settles down. Good. Give an example of liquid 1 and liquid 2. Liquid 1 is oil while liquid 2 is water. Indicate the physical property on which this technique depends. Let's look. 2 layers are observed, one settled and the other flowed. Good, it's density. Can this technique be used to separate alcohol from water? Justify. Think, take a few seconds. Alcohol, water. No, good, because alcohol and water are two miscible liquids. Rearrange the following steps followed to separate water and oil. 1, 2, 3, and 4. Yes. Which one is the first step? Good. It's 3, where we place the mixture inside the separatory funnel. 2. Wait a few minutes. 4. Open the stopcock, allowing the passage of the denser liquid. And 1, we are totally separated. Then it's 3, 2, 4, 1. The agenda that by Amani Siblani, recorded by Amani Siblani, and supervised by Dalal Bais. Thank you for your attention and have a nice day.